management in Linux. In Linux, a file could be anything capable of handling input-output stream of data. Just like in Linux, it is not necessarily an object stored on disk or fetched over a network. And that is why it is very important to learn how file is managed in Linux. The implementation detail is hidden under the virtual file system. The virtual file system, it is designed around object-oriented principles. So it has two concepts. Number one, definition of what a file system object are allowed to look like, and number two, layer of software to manipulate the objects. Okay, so there are four object types. One, inode object. Number two, file object. Number three, superblock object, and number four, entry object. We will read about each of them as we go on. For each object, there is a set of function or operations. So each object contains a pointer to a function table. A function table contains a list of addresses of actual functions that implement the defined operation for that object. The functions could be something like open, read, map, etc. A VFS layer can perform operation on one file system object by calling the appropriate function from the object's function table without knowing anything about the type of object. Inode and file object. So the file object, it provides a point of access to the data in an open file. It keeps track of where in a file a process is currently reading or writing, and it typically belongs to a single process. That is to say, one file object for every instance of an open file. Inode object, it is a data structure containing pointer to the disk blocks that contain actual file content. It maintains info about each file, such as owner, size, time recently used, etc. Even when it is not used, and it is stored or cached by the VFS. That improves the time or performance of the CPU. But also there is only a single inode object for one file. There can be multiple file objects, but there is only one inode object. And a process cannot access an inode object's content without first obtaining a file object. And we have another type of file, that is directory file. It supports creating, deleting, and renaming a file in a directory. So it is defined in a inode because it is not necessary to open a file to create, delete, or rename it, right? Next is superblock object and entry object. The superblock object represents a connected set of files that form a self-contained file system. That is a single object for each disk device mounted, and it also provides access to the inodes. VFS gives the inode number to the superblock object and get in return the inode object. A entry object represents an directory entry. The Linux ext3 file system is the on-disk file system used in Linux. ext3 does not use fragments at all, but performs all its allocations in small units like 1 to 8 KB. Default block size varies with the size of the file system. It allocates logically adjacent blocks into physically adjacent on disk, thus reducing overhead. The ext3 file system is partitioned into multiple segments. These are called block groups. So, allocation in ext3 file system. So, first it selects the block group. For data block, it attempts to allocate to the block group of its inode. For inode, it selects the block group in which the file's parent directory resides for non-directory files. And for directory files are spread across available block groups. These are done to reduce fragmentation of any one area of disk and keep related info close. Now, allocation within a block group. So ext3 maintains a bitmap for free block in a block group. While allocating the first block for a new file, it starts by searching for a free block from beginning of the block group, and when extending a file, it searches from the block most recently allocated. There are two stages of search. Number one, entire free byte in bitmap, and number two is any free bit. The entire free byte is searched for to try and allocate in chunks. So once a free block is encountered or identified, the search is extended backward until a non-empty block is encountered. This prevents ext3 from leaving holes between two allocations. After this, it extends the allocation forward up to 8 blocks and pre-allocates them to the file. This reduces fragmentation and also reduces the CPU cost of disk allocation by allocating simultaneous blocks. Pre-allocated blocks are returned to free space once file is closed. Journaling. So modification to the file system are written sequentially to a journal. This is called journaling, and it is written as transactions. A transaction is a set of operations that perform a specific task. Once a transaction is written in journal, it is considered committed. Journal entries are replayed across the actual file system structure in due time. A pointer is updated to indicate completed actions, and a journal is actually a circular buffer. So if in any case the system crashes, the incomplete transaction remains in journal. It is completed after recovery. If a transaction is aborted, the system is or undoes the changes made. Costly synchronous random I/O are turned into less costly synchronous sequential writes to the file system. And there is another file system, that is a Linux process file system. It contains one file for each active process with PID of that process for the file name. A file with PID 0 represents a global info like the kernel version, free memory, performance statistics, etc. Thank you.